Where is the center of the universe? Since humans first looked up at the sky, they have posed an ancient and perplexing question. Where is the center of it all? This audiobook explores that mystery with the help of modern science, traversing theories, observations, and surprises that could forever change your perspective on the universe. Since ancient times, humans have gazed at the sky in awe. Every star, every planet, and every comet was a reference point in their understanding of the world. However, the idea of a center of the universe has been a topic of debate for philosophers and scientists alike. Is the Earth the center, as the ancient Greeks believed, or is the sun the focal point, as proposed by Renaissance astronomers? This dilemma has guided much of our scientific adventure. The importance of knowing where the center of the universe is lies not just in curiosity, it is about understanding the very structure of the cosmos. If the universe has a center, that could mean everything revolves around it. But what if there is no center? That leads us to rethink not only our position in space, but also our identity as human beings. Have you ever wondered why this question is relevant in modern cosmology? The answer lies in the fact that our understanding of the universe influences how we see ourselves and our history as a species. Science not only seeks answers, but also invites us to question our deepest beliefs. Every discovery we make about the universe can change the way we understand our existence. As we explore this question, we encounter a universe in constant expansion. If the universe is stretching, then the idea of a center becomes even more complicated. How can something expand without a central point? This question leads us to reflect on the very nature of space and time. In a sense, the universe could be like a balloon that is inflating. As it expands, all points on its surface move away from each other, but there is no point around which everything revolves. It is interesting to note that the concept of a center can be misleading. In geometry, a circle has a center, but the universe might be more like the surface of that balloon, where every point is equally valid. This idea challenges us to think beyond what we have learned in our classrooms. Sometimes the deepest answers are not in numbers or formulas, but in analogies that allow us to visualize what we cannot see. The history of cosmology is full of twists and surprises. The search for a center has led generations of scientists to explore the cosmos, to build telescopes and to send probes into space. Each advance has been a step toward understanding who we are and where we come from. But as we progress, we also encounter new questions that challenge our previous answers. Is it possible that we are searching in the wrong direction? The notion of a center also raises philosophical questions. If there is no center, does that mean we are alone in the vast universe, or that we are part of a greater whole? Cosmology is not just about stars and galaxies. It also delves into the realm of existence and meaning. Each discovery offers us a new perspective on our place in the cosmos. The idea that there is no center could even be liberating. In a universe without a focal point, each of us has a role to play. We are part of a vast web of matter and energy intertwined in a cosmic dance. The search for a center can be seen as a metaphor for our quest for meaning in life. Instead of seeking a fixed point, perhaps we should embrace the uncertainty and wonder of the journey. As science advances, so does our understanding of the nature of the universe. Modern cosmology has revealed that the universe is a dynamic place, full of mysteries and surprises. Each new finding invites us to rethink our theories and to think about the cosmos in ways we never imagined. The question of the center of the universe may just be the beginning of a much deeper journey. Since time immemorial, humans have looked up at the starry sky and wondered, what lies beyond? In ancient civilizations, the universe was not just a collection of stars in the firmament, but a reflection of their culture, beliefs, and knowledge. Thinking about the universe was like trying to understand a huge puzzle, where each piece represented a vision of life and the cosmos. But what was the shape of this puzzle in ancient times? Early societies, such as the Babylonians and Egyptians, conceived of the universe very differently than we do today. For them, the Earth was the center of the cosmos, surrounded by a sky that, in their imagination, was a kind of dome over their heads. This view is known as the geocentric model, where the Earth occupied a privileged position like a king on a throne. Isn't it curious to think that for millennia it was believed that everything revolved around us? Over time, brilliant figures like Aristotle and Ptolemy defended this model, arguing that it was the most logical way to understand the universe. In their conception, the planets and the sun moved in perfect spheres around the Earth, as if they were marbles in a bag. But what happened when a bold man decided to question this view? This man was Nicholas Copernicus, who in the 16th century proposed a revolutionary idea. The Earth was not the center of the universe. Instead, the sun occupied that privileged position. His heliocentric theory, although initially controversial, began to change the way we thought about our place in the cosmos. Imagine the surprise and resistance he faced when challenging such a deeply rooted belief. But who ultimately validated his ideas? It was the astronomer Johannes Kepler who, while studying the movement of the planets, discovered that they moved in elliptical orbits rather than perfect circles. Kepler not only supported Copernicus, but also provided a new understanding of celestial mechanics. Isn't it fascinating to think that as we moved away from the idea of being the center, we began to better understand how the universe works? However, the story does not stop here. At the end of the 19th century, a new protagonist appeared on the scene, the telescope. This invention allowed astronomers to see beyond what our eyes could capture. With its help, thousands of stars and galaxies were discovered, further expanding our perspective. But what if I told you that some of those galaxies were so far away that their light took millions of years to reach us? In this context, the conception of the universe transformed from a closed and limited space to a vast ocean of stars. The idea of an infinite universe began to gain traction. But how do these celestial bodies behave in such immense space? The answer was more complex than many thought. The galaxies were not just floating randomly. They were organized in a structure that scientists began to call the cosmic web. The cosmic web is like a huge fabric made up of filaments of matter, where galaxies cluster into groups. Each thread of this fabric is a pathway that connects galaxies throughout the universe. But what does this mean for our search for a center as we entered the 20th century? The idea that the universe has no center became increasingly evident. The notion of an expanding universe proposed by Edwin Hubble further challenged the idea of a fixed center. Hubble observed that galaxies were moving away from each other, as if they were on an inflating balloon. Isn't it amazing to think that instead of revolving around a central point, the universe is constantly expanding? When we observe the night sky, we may feel that the universe is an orderly and harmonious place. However, the reality is that it is a vast stage where matter and energy are distributed in complex ways, and yet the search for a center persists in our minds. Could we be seeking something that in reality does not exist? The conception of the universe has evolved from ancient beliefs in an Earth-centered cosmos to the modern understanding of an expanding and constantly moving universe. At each stage of this evolution, we have come closer to the truth, but at the same time, we have moved away from the idea of a fixed center. The question remains, if there is no center, what does this mean for us and our place in the cosmos? The search for answers about the structure of the universe leads us to rethink our existence and the connections we have with the vast universe that surrounds us. On this journey through time and space, we have learned that the universe is much more than a simple collection of stars. It is a place full of mysteries and wonders waiting to be discovered. And so, the journey continues. The expansion of the universe is a fascinating concept that leads us to rethink not only what we know about the cosmos, but also our position within it. What if I told you that the universe is not a static entity, but is in constant motion? That idea may seem surprising, but it is precisely what scientists have discovered through careful observations and innovative theories. But how did we come to understand that the universe is expanding? In the 1920s, an astronomer named Edwin Hubble made a series of observations that would change our perception of the universe forever. While observing different galaxies through his telescope, he noticed something intriguing. The farther away a galaxy was, the faster it seemed to be moving away from us. This relationship, now known as Hubble's law, reveals a crucial clue about the nature of the cosmos. But what does this really mean? Imagine you are at a party and decide to inflate a balloon. As the balloon expands, the small spots of ink you have drawn on its surface move away from each other. Each point represents a galaxy, and the balloon itself is space itself. As space expands, the points move apart, and that is exactly what happens with galaxies in our universe. This discovery led to the conclusion that the universe is not only expanding but doing so at an accelerating rate. But why does this happen? One of the questions that arise is, what is behind this expansion? The answer to that question takes us to explore the Big Bang, the moment when everything began. However, before reaching that initial explosion, it is essential to understand that the universe does not behave like a common object. It does not have a fixed center from which everything expands. Instead, every point in the universe acts as the center of its own space. This may sound confusing, but it is fundamental to understanding how the universe works on a large scale. The idea that the universe is expanding has led scientists to develop complex mathematical models. But the essence is that this expansion is not just a visual phenomenon, it has profound implications for how we perceive the history of the cosmos. If we go back in time, we can imagine a moment when everything was concentrated in a single point. But what was that point? The answer is that there is no point in the universe that we can point to as its center. Rather, everything was compressed into an extremely dense and hot state. Now, what does this mean for us? The expansion of the universe is not just a phenomenon occurring on colossal scales. It also affects the structure of galaxies, the distribution of matter, and ultimately our place in the cosmos. But what role does gravity play in all this? Gravity is the force that holds our galaxies together, while the expansion of the universe tries to separate them. This delicate balance is essential for understanding how the cosmos is organized. As we delve deeper into this topic, it is important to highlight that the expansion is not uniform. There are areas where gravity is stronger and where galaxies cluster together, forming groups and superclusters. In other parts, the expansion is more evident, and galaxies are moving away from each other at astonishing speeds. This cosmic dance is fascinating and leaves us with more questions than answers. One of the most intriguing aspects of the expansion of the universe is that as galaxies move away, they also shift towards the red. This phenomenon, known as redshift, is like listening to a train moving away from us. The sound becomes lower as it moves away. In the case of the universe, the light from distant galaxies shifts to longer wavelengths, indicating that they are moving away from us. However, despite its apparent simplicity, the expansion of the universe is a topic full of mystery. What drives this acceleration? Many scientists suggest that it could be due to an unknown force called dark energy, which represents a significant portion of the universe's energy content. But what is dark energy, and how can we better understand it? That is one of the great questions of modern cosmology. The expansion of the universe invites us to reflect on our position in the cosmos. As we move away from the Earth-centric view of the universe, we begin to see ourselves as part of a vast and dynamic system. This leads us to question not only how the universe works, but also the purpose of our existence within it. The expansion of the universe offers us a unique perspective on time and space. By understanding that the universe is in constant motion, we also learn that our history is one of change and transformation. The expansion is not just a physical phenomenon, it is a metaphor for evolution and growth, both in the cosmos and in our own lives. In summary, the expansion of the universe is not just a scientific concept, but a reminder of the wonder and mystery that surrounds us. As we look up at the starry sky, we may ask ourselves, what other secrets will the universe reveal to us as we continue to explore? The story of the expansion of the universe is just the beginning of an adventure unfolding before us, inviting us to keep inquiring and learning. What is the origin of the universe? This is a question that has fascinated scientists and philosophers for centuries. At the heart of this issue lies the Big Bang model, a monumental explosion that, according to the theory, initiated everything we know. But what does the term Big Bang really mean, and how was this conclusion reached? To understand the Big Bang, we must first imagine the universe as a balloon. When we inflate a balloon, the parts of its surface move away from each other. In this case, the balloon represents the universe, and the points on its surface are galaxies. Initially, this balloon was completely deflated, concentrating all matter and energy in an infinitely small and dense point. At some moment, this point began to expand, but what caused this explosion? The idea that the universe is expanding comes from observations by Edwin Hubble, who in the early 20th century noticed that galaxies were moving away from us. Why is this so surprising? Because if galaxies are moving away, it means that at some point everything was much closer together. This observation led to the conclusion that the universe has not always been as we see it today, but has been in a constant state of expansion since its creation. Now, if we think of the Big Bang as the beginning of everything, another fascinating question arises. How did this event occur? The theory suggests that at the moment of the Big Bang, the universe was extremely hot and dense, filled with subatomic particles in a state of chaos. As the universe began to expand, it started to cool down. This cooling allowed particles to combine to form the first atoms, primarily hydrogen and helium. As the universe continued its expansion, these clouds of gas began to group together under the influence of gravity, forming the first stars and galaxies. It's like having a fruit smoothie. At first, all the ingredients are mixed in one place, but when we start blending, each fruit takes its place. The stars, like the fruits in our smoothie, began to take shape and organize into more complex structures. One of the wonders of the Big Bang is that it not only gave rise to matter, but also to time and space. Before this event, time as we know it did not exist. This leads us to ponder, what was there before the Big Bang? The answer is perplexing. There was no before, as time itself began at that moment. It is a difficult concept to grasp, but it invites us to think about the nature of existence itself. As the universe expanded, fascinating phenomena also occurred, such as the formation of the cosmic microwave background radiation. This echo of the Big Bang, which we can still detect today, is like a fingerprint of the moment the universe was formed. By studying this radiation, scientists can gain clues about the initial conditions of the universe. The Big Bang theory is not without controversy. Some people wonder if it is the only possible explanation for the origin of the universe. Could there be other models that explain what we observe? However, the evidence accumulated through observations and experiments has remarkably supported the Big Bang theory. While we may not have all the answers, the evidence is compelling. Moreover, the Big Bang not only explains the origin of the universe, but also raises new questions. For example, how will galaxies evolve in the future? Will the universe continue to expand forever? Or will it eventually stop and begin to contract? These questions are part of the exciting field of cosmology, where scientists attempt to unravel the mysteries of the cosmos. It is fascinating to think that all of us, Every human being, every star, every planet are essentially products of that first moment of the Big Bang. Isn't it amazing? We are made of the same elements that formed in the early moments of the universe. So, in a way, we are all part of this cosmic story. The exploration of the Big Bang also invites us to consider the role of science in our understanding of the universe. Through research and discovery, we have been able to build a framework that helps us understand our existence. However, the universe remains a place full of mystery. Every answer we find often leads us to more questions. In summary, the Big Bang not only represents the beginning of the universe, but also a continuous journey of discovery. As we explore this theory, we delve into a vast ocean of possibilities and questions that challenge us to keep seeking the truth about our place in the cosmos. What other surprises does the universe hold for us? The search has only just begun. If you're enjoying this journey through the universe and want to keep exploring more cosmic mysteries, don't forget to subscribe to the channel and give the video a like. Thank you for being part of this Star Odyssey. Einstein's relativity is one of those concepts that may seem complicated, but at the end of the day, it is a way of viewing the universe around us in a completely new light. What if I told you that time and space are not fixed, but can change depending on how we move? That's right. This revolutionary idea was introduced by a man who changed the way we understand physics, Albert Einstein. First, let's think about how we normally conceive of time. For us, time is a straight line that moves forward uniformly, but according to Einstein, time can stretch or contract depending on the speed at which we travel. Can you imagine that if you traveled at a speed close to that of light, you could experience time differently from your friends on Earth? It's as if your personal clock were in a different dimension. This is known as time dilation and is one of the most surprising predictions of the theory of relativity. On the other hand, relativity also tells us how gravity behaves. Instead of thinking of gravity as a force pulling objects toward the center of a planet, Einstein described it as a curvature in space-time. Imagine space as a large elastic sheet. If you place a heavy ball in the center, the sheet sinks. Now, if you put a marble nearby, it will start to roll toward the heavy ball due to the curvature created. This is how gravity acts in the universe. Large objects, like planets and stars, curve the space around them, causing other objects to move toward them. An intriguing question is, how does this affect the way we see the universe? Relativity tells us that light is also affected by the curvature of space. When light passes near a massive object, like a star, it bends slightly. This phenomenon is called gravitational lensing and allows us to see things that would otherwise be hidden. Imagine you are in a field looking at the stars. If there is a large mass in the middle, like a galaxy, the light from the stars behind that galaxy bends and can create distorted or even duplicated images of those stars. Relativity not only helps us understand what happens in the cosmos, but it also has practical applications in our daily lives. Did you know that global positioning systems, or GPS, must take relativity into account to function correctly? The satellites orbiting Earth move at a different speed than we do on the surface, and their time dilates. Without those adjustments, your maps and directions would be constantly incorrect. It's incredible to think that a theory that seems so abstract has such a real impact on the technology we use every day. As we delve deeper into relativity, it is essential to understand that there are two main parts to the theory. The first is special relativity, which focuses on objects moving at constant speeds, and the second is general relativity, which includes gravity and how it affects space-time. Special relativity tells us that nothing can exceed the speed of light, but what does this really mean? Think of a race between two cars. If one of the cars is traveling at the speed of light, the other will never be able to catch up. It is a barrier that so far seems insurmountable. On the other hand, general relativity is what transforms our understanding of the cosmos. This approach leads us to the conclusion that the universe is a dynamic place where time and space are interrelated. If space is expanding, as the Big Bang theory suggests, then time must also be expanding. This leads us to a new way of thinking about the history of the universe and its future. If the universe continues to expand, what does this mean for time? Are we on a journey that has been happening for billions of years and is still far from over? Thinking of the universe as a constantly moving fabric helps us visualize how matter and energy interact. Relativity suggests that, at a fundamental level, everything is connected. Every star, every galaxy, every tiny atom in your body is influenced by this cosmic dance of space and time. It's as if we are in a great orchestra, where every note and every instrument contributes to the symphony of the universe. One of the most fascinating questions that arises from relativity is, if time can stretch or shorten, what does this mean for our perception of reality? If time is not absolute but varies, could we, in theory, travel through time? Science fiction has explored this idea, but so far, relativity has given us more questions than answers about the nature of time. Einstein's relativity not only changed our understanding of the universe, but it also opened the door to a world of possibilities. It has led us to question concepts that we once considered unmovable and to explore new frontiers in physics. Every discovery we make from this theory brings us a little closer to understanding the vast and mysterious cosmos in which we live. So, as we reflect on relativity, it is important to remember that it is not just about formulas and equations. It is about our human quest for knowledge and how we fit into this immense universe. It reminds us that although we may feel small in the vastness of the cosmos, our questions and curiosities are what define us as a species. Relativity is not just a theory, it is a journey toward understanding what it means to be part of this ever-evolving universe. The geometry of the universe is a fascinating topic that invites us to reflect on how we understand the cosmos. Have you ever thought about what the shape of the universe might be? For many, the idea that the universe has a defined shape may seem strange, but it is a crucial aspect of cosmology. There are three main configurations that scientists consider: flat, closed, and open. Each of these geometries has profound implications for the fate of the universe and its structure. First, let's imagine a flat universe. This concept may be easier to visualize. Think of a sheet of paper that extends infinitely. In this model, parallel lines never meet, and light travels in a straight line. A flat universe suggests that the density of matter and energy is exactly the critical amount needed to balance the force of gravity and expansion. This means that in the distant future, the expansion of the universe could continue forever, but at an ever slower rate. On the other hand, closed geometry resembles the surface of a sphere. If you imagine walking on a sphere, you could return to your starting point without deviating. In a closed universe, gravity is strong enough to stop the expansion and eventually cause the universe to collapse in on itself. This idea can be unsettling, as it implies a future where everything could come back together at a single point. But are we really in such a universe? Now, the open model is even more intriguing. Imagine a universe that resembles a saddle, where parallel lines eventually diverge. In this scenario, the universe has a density of matter less than the critical amount, meaning that the expansion will not only continue, but will accelerate over time. This relates to the mysterious dark energy, which seems to drive the expansion of the universe. But what does this mean for us? One of the most intriguing questions that arise from these geometries is, what does the shape of the universe tell us about our place in it? Whether we are in a flat, closed, or open universe, how does this affect the way we view the cosmos? The geometry of the universe not only influences its fate, but also how we perceive space and time. The next question is, how do we determine which geometry best describes our universe? This is where astronomical observations come into play. Scientists use telescopes and other instruments to measure the distribution of galaxies and cosmic background radiation. By analyzing this data, they can infer the geometry of the universe. This process is like trying to piece together a cosmic puzzle, where each piece provides valuable information about the overall shape. As we delve deeper into this topic, another question arises. What if the geometry of the universe is neither completely flat, closed, nor open? Some physicists suggest that it could be something more complex, a mixture of these geometries. Imagining a universe that combines elements of all these models is a fascinating exercise that challenges our understanding. It is interesting to reflect on how these ideas affect our perception of reality. If the universe is truly flat, that could imply we are living in an infinite space. But if it is closed, we might be in a finite system, where everything is connected in ways we do not yet fully understand. On the other hand, an open universe could suggest a future where expansion never stops, raising questions about the ultimate fate of everything we know. As we explore these notions, it is essential to remember that the geometry of the universe is not just an academic question. It has profound implications for the nature of time, space, and matter. It leads us to question not only what the universe is like, but also how we are connected to it. Could it be that the shape of the universe influences our daily existence? The quest for answers to these questions takes us into unknown territory. Scientists continue to investigate and explore using the most advanced technology to unravel the secrets of the cosmos. Each discovery brings us a little closer to understanding how the universe is organized and what our place in it is. Ultimately, the geometry of the universe is a window into the unknown. It challenges us to think beyond our everyday perceptions and consider the vastness of what surrounds us. By exploring these ideas, we not only learn about the cosmos, but also reflect on our own existence in a vast and mysterious universe where shape and structure are just part of the enigma we seek to solve. So the next time you look up at the starry sky, ask yourself, what is the shape of the universe? And most importantly, what does that mean for all of us? The answer may be more surprising than you ever imagined. The pursuit of cosmic knowledge is, ultimately, a quest for ourselves. What is critical density, and why is it so important for understanding the universe? To start, imagine that the universe is like a huge balloon. When we inflate it, the balloon can expand in different ways. Sometimes it may expand so much that it becomes very thin and fragile. Other times it may maintain a compact and firm shape. Critical density is the point that determines how our universe will behave as it expands. If the density of matter in the universe is greater than this critical density, the universe could stop expanding one day and start contracting, as if the balloon began to deflate. But what would happen if the density is less than critical? In that case, the universe would continue to expand indefinitely, like a balloon that keeps inflating without stopping. Now, if the density is exactly equal to critical density, the universe would expand forever. But it would do so at an increasingly slower rate, as if it were taking a deep breath. To better understand this, let's think of a simple experiment. Imagine you are at a party with balloons. If there are more people inflating balloons than there are balloons, it's likely that some balloons will pop or deflate. But if there are just the right number of people, all the balloons can inflate properly and remain in balance. In the universe, critical density acts like that just right amount that determines whether the universe expands eternally or eventually collapses. Critical density is not a fixed number. In reality, it depends on the rate of expansion of the universe and the amount of matter and energy it contains. Scientists have calculated that, at present, critical density is approximately equal to a specific amount of matter and energy per cubic meter of the universe. But how do we know if we are above, below, or right at the threshold of this critical density? This is where the observations and calculations of astronomers come into play. Through telescopes and satellites, scientists can measure the amount of visible matter, such as stars and galaxies, as well as dark matter, which we cannot see directly, but know is there due to its gravitational influence. With this data, they can estimate the total density of the universe. One of the most intriguing questions is, what if the total density of the universe turns out to be less than critical? This would mean that the universe is expanding forever, which could lead to a cold and empty future where galaxies drift apart until darkness and silence reign. On the other hand, if the total density is greater than critical, the future could be very different. Imagine a universe that begins to collapse, where galaxies come closer and eventually collide. That could be an explosive end known as the Big Crunch. What if the density is exactly critical? In this case, the universe could expand and slow down forever, but never stop completely. It would be a perfect balance, a delicate dance between expansion and gravity trying to pull everything back together. In recent years, a new element has emerged in this equation: dark energy. It has been discovered that this mysterious form of energy is driving the acceleration of the universe's expansion. This adds an additional layer of complexity to our understanding of critical density. While we know that dark energy accounts for a large part of the total density of the universe, we still do not fully understand how it relates to critical density. Another fascinating question is, could critical density change over time? As the universe expands, the amount of matter may disappear or transform, and dark energy could play a different role in the future. This poses an intriguing dilemma for cosmologists. Are we on the brink of a monumental change in the way we understand the universe? Critical density is not just a number, it represents a boundary that helps us understand the fate of the universe. It reminds us that there is a delicate balance in nature where small variations can have enormous effects. This concept also invites us to reflect on our own existence in the cosmos. If the universe is a constantly expanding balloon, what role do we play in this vast and complex reality? In summary, critical density is a fundamental concept in cosmology that allows us to explore deep questions about the structure and fate of the universe. From the way it will expand to its possible end, this concept invites us to view the cosmos not just as a physical place, but as a constantly evolving mystery that we are still trying to unravel. So, as we continue to seek answers, let us remember that each discovery brings us a little closer to understanding not only the universe, but also our place in it. In the vast universe, there is a limit that seems to delineate what we know and what lies beyond. This limit is called the cosmic horizon. But what is it exactly, and why is it so important to understand it? We must first think of the universe as a bubble expanding. Imagine the universe as a balloon being inflated. As the balloon grows, all the little marks you drew on its surface move away from each other. In this context, the cosmic horizon is the boundary of what we can see and know from our viewpoint on Earth. An intriguing question is, why can't we see beyond this horizon? The answer lies in the speed of light. Light travels at an incredibly fast speed, but the universe is so vast that there are areas we have not yet been able to observe because the light from those places has not had enough time to reach us since the beginning of the universe. This means there is an area of space that is completely inaccessible to us simply because light from there has not arrived. Isn't it fascinating to think that there are parts of the universe that remain a total mystery? The cosmic horizon also speaks to us about time. When we look at a distant star, what we are really seeing is how that star was in the past. If the star is 1,000 light years away, the light we see today began its journey 1,000 years ago. So, every time we gaze at the sky, we are looking back in time. But what happens when the light from a galaxy has not yet reached our horizon? We will never know what that galaxy looks like at this moment. This raises a dilemma. What lies beyond our horizon? Could there be other galaxies, other forms of life, or even other realities? As we understand the cosmic horizon, we encounter another intriguing concept: the expansion of the universe. As the universe expands, our cosmic horizon also expands. This means that over time we might come to see more and more of what is out there. But here arises another question. Is there a limit to that expansion? Perhaps in the distant future, some of the objects we currently consider visible will fade once again beyond the horizon, and we will never see them again. The idea that the universe might be playing hide and seek with us is as captivating as it is unsettling. Speaking of the nature of the horizon, it is interesting to note that it is not a fixed limit. As the universe continues to expand, the galaxies that are now at the edge of our horizon could become part of our field of vision in the future. However, this depends on the rate at which the universe is expanding. If the expansion accelerates, some galaxies will move away from us so quickly that their light will never reach our eyes. Isn't it amazing to think that the universe is in constant motion, changing and evolving even as we speak? The cosmic horizon also has philosophical implications. What does it mean for us to know that there is a limit to our ability to observe the universe? It invites us to reflect on our position in the cosmos, to question our significance and our place in a vast stage that seems to have no end. The limitation in our vision can also be a reminder that, although we have made progress in understanding the universe, there is still much we do not know and perhaps never will. Moreover, the concept of the cosmic horizon helps us understand why certain regions of the universe are more difficult to study than others. Areas that lie beyond our horizon are essentially invisible to us, making it challenging to create maps of the cosmos. This raises the curious idea that we might be living in a region of space that is only a small fraction of a much larger and more complex universe. Could it be that other intelligent beings in different parts of the universe are facing the same dilemma as us, the inability to see beyond their own horizon? With advances in technology and science, astronomers are finding ways to infer what lies beyond our cosmic horizon. Using cosmic background radiation and other methods, scientists are beginning to gather clues about what exists beyond what we can directly observe. However, these inferences are just that, conjectures based on limited data. Is it possible that one day we can break the barriers of our horizon and discover what lies beyond? The quest for answers to these questions is what drives human curiosity. Finally, the cosmic horizon is not just an abstract concept, it also relates to our pursuit of knowledge. It reminds us that science is a constantly evolving journey. Each discovery leads us to new questions, and each answer opens doors to a universe of possibilities. In this sense, the cosmic horizon is a symbol of our innate curiosity and our desire to explore the unknown. As we continue to explore the cosmos, we must never forget that, although there is a limit to what we can see, that does not limit our imagination. The cosmic horizon invites us to keep asking, to keep searching, and to not stop in the face of the universe's mysteries. In an era where information is at our fingertips, the challenge is not just to know more, but also to learn to appreciate what is still beyond our reach. Have you ever felt that there is something mysterious in the universe, something we cannot see but that influences everything around us? That is the essence of dark matter, one of the most intriguing and elusive pieces of the cosmic puzzle. Although we cannot see or touch it, scientists are sure it is there, and it is fundamental to understanding how the universe is organized. But what exactly is dark matter and why is it so important? To understand dark matter, it is helpful to think of a party. Imagine you are in a room full of people, but there is a large part of the space that is empty. However, you feel that the room is fuller than it seems. This happens because there are people in the back that you cannot see, but who influence how the space feels. Similarly, dark matter is that invisible presence that affects the behavior of galaxies and the visible matter we can observe. Astronomers began to suspect the existence of this mysterious matter in the 1930s. When observing how galaxies moved, they noticed something strange. The stars at the edges of galaxies were moving at much higher speeds than expected. How could this be possible if we only take into account the visible matter? Galaxies should be falling apart, but instead they remain intact. This led to a fascinating conclusion. There must be something else out there, something we cannot see but that has mass and gravity. Dark matter does not emit light, nor can it be detected by telescopes, making it extremely difficult to study, but its presence is felt through its gravitational influence. Can you imagine having to discover something you cannot see? That is exactly what physicists and astronomers do. They use mathematical models and observations of galaxy movements to infer its existence. It's a bit like playing a game of cosmic guessing. To put it in perspective, it is estimated that approximately 95% of the universe is made up of dark matter and dark energy, while only 5% is formed by the matter we know, such as stars, planets, and galaxies. It's amazing to think that we are surrounded by such an overwhelming amount of matter that we cannot directly detect. One of the most accepted theories about the nature of dark matter is that it is composed of subatomic particles that do not interact with normal matter, except through gravity. These particles are known as WIMPs, which stands for weakly interacting massive particles. Although their existence has not yet been confirmed, scientists are working hard to detect them. Can you imagine being the first to find the key that could unlock the secrets of the universe? The search for dark matter is a global effort. There are underground laboratories, particle collision experiments, and observatories designed to discover these mysterious particles. Every time a scientist finds a clue, the world stops for a moment. It's like a cosmic thriller where each chapter reveals a new twist in the plot. But why is it so crucial to understand dark matter? The answer lies in the fact that its influence affects the very structure of the universe. Without it, galaxies could not form in the way they do. Imagine the universe as a huge fabric, where dark matter acts as the thread that holds everything together. Without that thread, stars and planets would have no framework to support them. Moreover, dark matter also plays a vital role in the expansion of the universe. As the universe expands, dark matter acts as a counterweight. Its gravity moderates the expansion, helping us understand the ultimate fate of the cosmos. Will the universe continue to expand indefinitely? Or will it eventually stop and begin to collapse? The answer may depend on how much dark matter there really is. Computer simulations have allowed scientists to recreate what the universe would look like if dark matter did not exist. The result is fascinating. Galaxies would group together differently, forming a completely different cosmos. This exercise helps us appreciate the importance of dark matter in the design of the universe as we know it. So, when you look up at the starry sky, remember that there is much more than meets the eye. The bright stars and constellations are just a small part of a vast and complex cosmic stage. Dark matter, although invisible, is fundamental to the very existence of everything we see. Isn't it amazing to think about the mysteries that still remain to be discovered? As we continue our exploration of the universe, dark matter will remain a central topic. Scientists are constantly in search of answers, and each new discovery brings us one step closer to unveiling the secrets of the cosmos. The truth about dark matter could change our understanding of the universe forever. And who knows, maybe one day we will be able to see what is now hidden. In the meantime, the search for dark matter reminds us that although there is much we do not know, every question we ask brings us closer to a greater understanding of our place in the universe. Did you know that the universe is not only expanding but is also being driven by a mysterious force? This force is called dark energy, and although we cannot see or touch it, its influence on the cosmos is monumental. Imagine the universe as a balloon that is inflating, and dark energy is the air that fills it. Without this energy, the universe would behave very differently. But what exactly is dark energy, and why is it so crucial for our understanding of the cosmos? Dark energy represents approximately 70% of the total composition of the universe. However, despite its abundance, it remains one of the greatest enigmas of cosmology. Scientists around the world have dedicated themselves to investigating this force, but its secrets remain well guarded. Why, if it is so important, do we not know more about it? The answer lies in the very nature of dark energy, which seems to be a passive component of the universe rather than something that actively interacts with matter. So, how did we come to the conclusion that this enigmatic dark energy exists? It all began in 1998 when two teams of astronomers were observing distant supernovae. By studying the light from these stellar explosions, they realized that galaxies were not only moving away from each other, but were doing so at an ever-increasing speed. This was a surprising finding. Until that moment, many thought that the gravity of matter in the universe would slow down that expansion. But instead, it seemed that there was a force pushing the universe outward. This discovery not only changed our view of the cosmos, but also led to the formulation of the dark energy theory. Imagine you are trying to throw a ball upward. Gravity will pull it down to the ground, but if you suddenly encounter a strong wind that pushes the ball upward, the ball could continue its ascent despite gravity. Dark energy acts similarly, overcoming the gravitational pull of matter and accelerating the expansion. Despite its impact, the nature of dark energy remains a mystery. Is it a form of energy that fills empty space, a property of space itself? There are several theories, but none have been conclusively confirmed. Some suggest that dark energy could be a constant, an unchanging value that acts like anti-gravity. Other theories propose that it could change over time, complicating our understanding even further. It is fascinating to think that in such a vast and wondrous universe, such a subtle force can play such a dominant role. If we consider that the universe expands like a balloon, dark energy would be the air that inflates it. Meaning that as the universe grows, dark energy also becomes a fundamental part of that expansion. However, how can we study something that we cannot see or measure directly? Scientists have developed tools and methods to try to understand dark energy. One way they investigate it is through the observation of the large-scale structure of the universe. By studying how galaxies cluster and interact with each other, researchers can infer the influence of dark energy. They also use advanced telescopes and space missions, such as the Euclid satellite from the European Space Agency, which will seek to map the distribution of matter in the universe and unravel the mysteries of this energy. Now, what is the impact of dark energy on our future? If dark energy continues to dominate the universe, we could face a future where galaxies move so far apart from each other that they eventually become completely isolated. This is known as the Great Blackout. On the other hand, if dark energy were to change over time, there could be a future where the expansion of the universe stops and eventually reverses, leading to what is called the Great Collapse. These are intriguing speculations, but we still do not have definitive answers. The The quest to understand dark energy is not just a scientific journey, it is also a philosophical one. If the universe is driven by a force we do not understand, what does that mean for our existence? How do we fit into a cosmos that is constantly changing and expanding? These questions lead us to reflect on our own nature and our place in the universe. As science advances, more efforts are being made to unravel the mysteries of dark energy. Perhaps in the future we will obtain answers to these intriguing questions and better understand how our universe is structured and behaves. Dark energy is a reminder that despite our advances, there is still much to discover and understand in the vast cosmos that surrounds us. So, the next time you look at the stars, remember that there are invisible forces at play. Dark energy is not only an essential component of the universe, but also a symbol of human curiosity and the desire to understand the unknown. In this journey toward knowledge, each discovery about dark energy brings us one step closer to answering the deepest questions about the universe and our place within it. Have you ever stopped to think about how the universe is organized on a large scale? The vastness of the cosmos is more than just a sea of stars and planets. It resembles a gigantic cosmic web that stretches across billions of light years. In this vast network, galaxies are not distributed randomly. Instead, they form complex structures that tell us the story of the universe itself. The first question that arises is, what exactly is this large-scale structure? Imagine the universe as a huge spider web where each intersection of threads represents a galaxy. These galaxies are not alone. They are connected by filaments of dark matter that act as invisible bridges, linking them together. Thus, the universe becomes a place where galaxies cluster into groups, and these groups in turn form superclusters, creating a kind of cosmic fabric. But how did we know that the universe has this organization? As astronomers have observed the sky, they have noticed surprising patterns. If we look at a map of the universe on a large scale, we see that galaxies are not evenly distributed. Instead, they cluster into massive structures. While there are vast empty regions between them, sometimes referred to as voids, this distribution is not just a whim. It reflects the history of matter and energy from the Big Bang to today. Now, the next question we might ask is, what role does gravity play in all of this? Gravity is the glue that holds all this matter together. Each galaxy, with its own set of stars and planets, exerts a gravitational force that affects neighboring galaxies. Imagine you are at a partner dance. As you move, you influence your partner's movement. This is how gravity acts in the universe. Galaxies move and group together, forming larger structures. Sometimes, this cosmic dance can be chaotic. Galaxies can collide and merge, which can lead to the formation of new stars and solar systems. But what happens to dark matter in this context? Dark matter, which we cannot see but know exists due to its gravitational influence, plays a crucial role in the structure of the universe. It is believed to account for about 85% of the matter in the cosmos, and its presence helps keep galaxies bound together in clusters. And what about the filaments that connect these galaxies? Astronomers have observed that dark matter forms a network that guides the distribution of visible matter. This cosmic web resembles rivers flowing through a landscape. Dark matter acts like the water that carves the terrain of the universe, creating the structures we see today. In fact, some studies have revealed that galaxies tend to form groups along these filaments, where gravity is stronger. As we explore these structures, it is fascinating to think about the scale of what we are trying to understand. The distances in the universe are hard to conceive. When we talk about galaxy clusters, we are talking about groupings that can contain hundreds or thousands of galaxies, all in one place. But how do these clusters form? The answer lies in gravitational collapse. Matter in the universe, as it groups together, creates regions of high density that lead to the formation of clusters over time. As the universe continues to expand, these clusters also move away from each other, but there is something we must not forget. The expansion of the universe is not uniform. This means that some regions are expanding faster than others, which could lead to interesting interactions between galaxies in the future. In fact, some research suggests that we might witness collisions between galaxies in billions of years. Now, the cosmic web is not static. Like a spider web, it can change over time. Over the eons, gravitational forces continue to shape the cosmos. Galaxies cluster, collide, and merge while new stars and solar systems are born from this ongoing dance. Each new discovery we make about the structure of the universe brings us closer to understanding not only how it is, but also how it has come to be what it is today. But what implications does all this have for our understanding of the universe? The way matter is organized in the cosmos not only tells us about its history, but also impacts the fate of the universe. As we better understand these structures, we begin to glimpse how the cosmos might evolve in the future. Will it continue to expand indefinitely, or will gravity one day dominate and lead to a collapse? Finally, it is important to reflect on what all this means for us, human beings. We are a small part of this vast cosmic web, a bubble of matter and energy amid the immense fabric of the universe. Every star we see in the sky and every galaxy we observe are reminders of the incredible complexity and beauty of creation. In our quest to understand the cosmos, we discover not only the universe but also our place within it. How many times have we looked up at the sky on a starry night, feeling small in the face of the vastness of the universe? The idea that the cosmos is a vast ocean of stars and galaxies can be overwhelming. But there is a fascinating principle that helps us understand it, the cosmological principle. This concept tells us that, on very large scales, the universe behaves in a homogeneous and isotropic manner. But what does this really mean? To understand it better, let's think about a balloon. Imagine you draw dots on the surface of that balloon. As you inflate the balloon, those dots move away from each other. However, there is no point on the surface that can be considered the center of the dots. They all move away from each other as the balloon expands. In the same way, the cosmological principle suggests that, in the grand scheme of things, there is no center of the universe from which everything expands. This can be a disconcerting concept, but it has profound implications for our understanding of the cosmos. In this sense, homogeneity implies that if we take a large portion of the universe, matter and energy are distributed uniformly in that area. But is this really what we observe? If we look closely, we notice that there are denser regions, like clusters of galaxies, and others that are emptier. However, when we observe the universe on sufficiently large scales, those irregularities smooth out and homogeneity becomes evident. But what about isotropy? This refers to the fact that no matter where we look, the universe appears approximately the same in all directions. What does this imply for our position in the cosmos? If the universe is isotropic, that means there is no privileged location. All observers, regardless of their location, will see the universe in a similar way. It's like being at a party in a round room. No matter where you are, you will always see the same people and decorations. This idea is fundamental because it suggests that we are not the center of the universe, but rather part of a vast whole. Now, this leads us to intriguing questions. If the universe is homogeneous and isotropic, what happens to theories that suggest there are special structures in the cosmos? Could there be regions of space where the laws of physics behave differently? These are questions that scientists continue to explore. There are theories that suggest there could be local variations, but the cosmological principle remains a fundamental pillar in our understanding of the universe. Despite this, the cosmological principle is not merely a statement without basis. It is grounded in observations. The cosmic microwave background radiation, which are the echoes of the Big Bang, is distributed almost uniformly across the sky. This is key evidence that the universe on large scales is indeed homogeneous and isotropic. But why is this uniformity important? It helps us build models of the universe that can predict its behavior and evolution over time. The idea of a homogeneous universe also holds that its history does not depend on our position within it. Think of a great book where each page tells the story of the universe. Each page is equally important, and together they form a narrative that does not center on a single character or place. Thus, the cosmological principle tells us that the history of the universe is a collective narrative. However, despite this homogeneity, the universe is full of wonders, galaxies, stars, planets, all a part of a complex web that, although it may seem chaotic on a small scale, conforms to this principle when observed in its entirety. But this balance also raises questions. What lies beyond what we can see? Are there regions of the universe that we will never be able to observe due to accelerated expansion? Human curiosity has always driven the search for answers. As we advance in our understanding of the universe, we may discover that the cosmological principle is not an endpoint, but a starting point. Theories about the nature of the universe, such as dark energy or dark matter, could change our perception of the homogeneity and isotropy of the cosmos. In a more philosophical sense, the cosmological principle invites us to reflect on our place in the universe. If there is no center, if we are all part of a vast whole, what does that mean for our existence? It can be liberating to think that we are connected to a larger cosmic fabric rather than being mere isolated observers. Finally, as we continue to explore the universe, the cosmological principle reminds us that there is still much to discover. Each new observation, each new finding can shed light on the questions we ask. So, while the notion of a center of the universe may seem alluring, perhaps the true beauty lies in the understanding that we are part of a vast and wondrous cosmos that continues to expand and reveal its secrets. The idea of a multiverse is as fascinating as it is perplexing. What if I told you that the universe we know might be just one among many, even infinite? This notion that there are other universes, each with its own laws of physics, history, and form, leads us to question everything we know about our place in the cosmos. Is it possible that there are realities where things are completely different from what we experience here? Visualize a bubble in a vast ocean. This bubble represents our universe, but in this ocean there are many other bubbles, each isolated from the others. Some may be similar to ours, while others could have completely different laws of physics. This image is not only exciting, but also raises profound questions about the nature of reality itself. What does it mean to be part of a single universe in a sea of possibilities? The theory of the multiverse is not just a fantasy of science fiction. Philosophers and scientists have debated it for decades. Some propose that based on certain quantum theories, every decision we make could create a new universe, just like in a book where you can choose different endings. Each choice could lead to a new story in another universe. Can you imagine how many universes could exist just from the decisions we make every day? One of the most intriguing arguments about the multiverse comes from cosmic inflation, a theory that suggests that just after the Big Bang, the universe expanded at an incredible speed. This exponential expansion could have created patches of space that became independent universes. Thus, ours would be just one of those patches. What implications would this have for our understanding of time and space? If there are other universes, how does that affect our quest for answers about life and existence? The idea of a multiverse also challenges our notion of what it means to be unique. In a vast ocean of universes, the uniqueness of our own universe could be diluted. However, this could also offer comfort. If there are other universes where things are different, could we find hope in the existence of realities where the problems we face here do not exist, where happiness, peace, and harmony are the norm? Science often seeks tangible evidence, but in the case of the multiverse, evidence may be elusive. If these universes are indeed independent, how could we ever observe or measure them? This leads to a fascinating question. Could the effects of these other universes, even if invisible, influence ours? The interconnectedness between them might be more subtle than we think. Not everyone agrees with the idea of the multiverse. Some scientists argue that without direct evidence, it is merely a speculative theory, but isn't science in many ways a constant search for the unknown? The exploration of the multiverse pushes us to rethink the boundaries of knowledge and open our minds to new possibilities. Should we accept the idea of the multiverse as a valid possibility, even if we cannot prove it at this moment? If the multiverse is real, then the meaning of life could change radically. In a universe where every possible outcome of our decisions materializes, what does our freedom mean? Are we truly choosing, or are our decisions simply a reflection of a vast network of already existing possibilities? This ethical and philosophical dilemma is another captivating aspect of this theory. Moreover, the notion of a multiverse could influence our search for extraterrestrial life. If there are other universes, what are the chances that there are forms of life in those worlds? We could be talking about civilizations that we will never know. But that could be so advanced that they challenge our current understanding of life and technology. What secrets could those distant universes hold? Finally, the multiverse invites us to reflect on the very nature of reality. Is our perception of life in this universe the only truth? The idea that we could be part of an infinite set of universes raises questions about existence, identity, and purpose. In the search for answers, we may discover that the questions are as important as the answers themselves. Thus, the theory of the multiverse is not only a fascinating concept from a scientific perspective, but also a mirror that reflects our own concerns and aspirations. It invites us to explore the unknown, to question what we think we know, and to imagine a cosmos that goes beyond our immediate understanding. Ultimately, it reminds us that in the vast immensity of the universe, there is always more to discover, more to learn, and more to dream. Who knows how many secrets we still have to unveil in the ocean of multiverses? Have you stopped to think about the idea of a center of the universe? It's an intriguing notion that has fascinated philosophers, scientists, and dreamers throughout history. Many of us have grown up with the idea that there is a central point in the vast cosmos, a place from which everything expands. But is it really possible for there to be a center in a universe that is continuously expanding? Let's begin to unravel this enigma. First, let's talk about how ancient thinkers imagined the universe. For centuries, it was believed that the Earth was the center of everything. This geocentric view made us feel special, as if we were the epicenter of the cosmos. However, over time, we learned that the Sun actually holds a prominent place in the solar system, and it moves among the stars of our galaxy, the Milky Way. The question persists: if the Earth is not the center, where is the center of the universe? The answer may surprise you. As astronomers began to study the expansion of the universe, they realized that there is no fixed point from which everything expands. Imagine a balloon being inflated. As air enters, every point on the surface moves away from the others. In this case, the balloon is the universe, and there is no center on its surface. Each point moves away from the rest, and that's how our cosmos operates. The Big Bang Theory, which describes the origin of the universe about 13.8 billion years ago, also helps us understand this idea. At that moment, everything we know was concentrated in a single point. But from that instant, the universe began to expand. Instead of a fixed center, what we have is a universe that expands uniformly in all directions. Can you imagine living in a place where distances are relative and the concept of a center blurs? This is precisely what modern cosmology shows us. Every galaxy is moving away from us, and the same goes for every star. If we look up at the sky, it seems that everything is moving, but there is no specific place we can point to as the center. Instead, each observer at any point in the universe would see other galaxies receding, creating an illusion of centrality from each position. Now, this raises another fascinating question. If there is no center, does that mean we are insignificant in the grandeur of the universe? It is often thought that not having a center implies that we are just a point in a vast cosmic ocean. However, that is not the case. Each of us is part of a cosmos that is constantly changing and expanding. Our existence is as significant as that of any other star or galaxy. The idea of a centerless universe also challenges our philosophical notions about our position in the cosmos. What does it mean to be human in a universe that has no focal point? It could be liberating to think that there is no privileged place, that life and matter can be found anywhere in the vast space. This also leads us to question our beliefs about purpose and meaning. Some might wonder if, despite the absence of a center, we could find a heart of the universe. It is a more poetic than scientific concept, inviting reflection on the interconnectedness of all things. Stars, planets, galaxies, all are part of an immense cosmic fabric where each thread has its function and place. We live in a universe that constantly surprises us. As telescopes and technologies advance, we discover more about the nature of the cosmos. Theories about the existence of a multiverse where other universes with their own rules and dimensions might exist also suggest that the concept of a center could be even more complicated to define. In the search for a center, we encounter dark matter and dark energy, components that play a crucial role in the structure of the universe. However, even these elements do not lead us to a fixed point. Instead, they show us that the universe is dynamic and mysterious, a place where questions are often more important than answers. As we delve deeper into these issues, it becomes evident that the universe is not just a vast void. It is a place where human curiosity has led to astonishing discoveries. Every time we look up at the sky, we are reminded that we are part of something much larger than ourselves, an expanding cosmos where the center is a concept that challenges our understanding. So, in the end, the question about the center of the universe invites us to explore, to question, and to marvel. The truth is that in this vast and enigmatic creation, we are not alone. Every star, every galaxy, every particle of matter that makes up the universe is in constant motion, and perhaps that is what really matters. Not finding a center, but understanding that we are all part of this grand cosmic adventure. What if I told you that there are tools that allow us to look into the past and understand how our universe was formed? Telescopes have been fundamental in this quest for knowledge. Since ancient times, we have looked at the stars and wondered what is out there. But with the advent of modern technology, we have been able to delve much deeper into those celestial mysteries. Telescopes are like great eyes peering into the cosmos. Through them, we have been able to capture the light from stars that are millions of light years away. That light, although it may seem just a flicker in the sky, is actually a time capsule that tells us stories about the universe's past. But how does all this work? Let's think of a lighthouse on the coast. When you see its light from afar, you don't just see a bright point. That light has traveled through air and water, and when it reaches your eyes, it tells you something about the distance and the place from which it comes. Similarly, when we observe the light from a distant galaxy, we are seeing how that galaxy looked billions of years ago. It's like receiving a letter from a friend who lives on another continent, telling you about their life in the past. The first great revolution in space observation came with Galileo's telescope in the 17th century. Before that, most people thought that Earth was the center of the universe. Galileo, by observing the moons of Jupiter and the rings of Saturn, showed that there was much more beyond our planet. But what if I told you that even that was just the beginning? With the development of more powerful telescopes, like the Hubble Space Telescope, our observational capabilities multiplied. Hubble has allowed us to see galaxies in formation, stars being born and dying, and has revealed phenomena that once seemed impossible to imagine. Did you know that thanks to this telescope, we have been able to observe galaxies over 13 billion light-years away? That means we are seeing light that has been traveling since shortly after the Big Bang. Every image we capture with these telescopes is a reminder of how vast and mysterious the universe is. But observing is not enough. We need to understand what we are seeing. This is where data interpretation comes in. Scientists analyze the images and light they capture to deduce the composition, age, and movement of celestial objects. It's like being detectives of the cosmos, searching for clues in the light that reaches us. Light waves are not the only ones telling us stories. Telescopes that detect radio or infrared waves have also expanded our perceptions. The cosmic microwave background radiation, an echo of the Big Bang, was discovered thanks to telescopes that capture those wavelengths. This radiation is a kind of noise that fills the universe, a remnant of the moment everything began. Isn't it fascinating? Moreover, there are telescopes working on other worlds, searching for exoplanets, that is, planets orbiting other stars. Some of these telescopes can even analyze the atmospheres of those distant planets for signs of life. This leads us to an intriguing question. Are we alone in the universe? Every new observation could give us an answer. Over time, technology has advanced, allowing telescopes to be placed outside the Earth's atmosphere. The images we obtain from space are much clearer and more detailed. Telescopes like the James Webb are designed to capture infrared light, revealing hidden secrets behind clouds of gas and cosmic dust. Can you imagine what we could discover with these advanced tools? The combination of all these telescopes has changed our understanding of the universe. We no longer see a static cosmos, but a dynamic place, constantly changing and expanding. We observe how galaxies are moving away from each other, confirming the theory of the universe's expansion. Each new discovery leads us to rethink what we know and to formulate new questions. On the other hand, not everything we observe is what it seems. Dark matter and dark energy are two concepts that have emerged from our observations. Although we cannot see them directly, their influence is undeniable. Telescopes have made us aware that the universe is much more complex than we imagine. With each new advance, our telescopes become silent witnesses to the history of the universe. They show us that although we are just a small part of this vast cosmos, every question we ask and every answer we find brings us a little closer to understanding our place in it. The quest for knowledge never ends. And every captured image is another step toward understanding who we really are and where we come from. So the next time you look at the starry sky, remember that behind every point of light is a story waiting to be told. Every star, every galaxy, every flicker in the darkness of space is a reminder of the wonder that is our universe. What will be the next great mystery that our telescopes reveal? The answer is on the horizon, waiting to be discovered. Gravity is one of the fundamental forces of the universe, and its influence is deeper than we can imagine. But how can this invisible force shape the structure of the cosmos? The answer to this question is fascinating and takes us on a journey through the vastness of space and time. When we think of gravity, we often relate it to what we feel on Earth, like when an apple falls from a tree or when we feel our own weight. However, gravity is also the architect of the universe on a grand scale. Imagine a huge canvas where stars, planets, and galaxies are drawn. Gravity acts as the brush that connects all these elements, creating a cosmic masterpiece. But what happens when gravity acts on a galaxy? How does it influence its shape and movement? Galaxies are not solitary islands in space. They are in constant interaction. The gravity between them is like a cosmic dance where each galaxy influences the others. The larger ones act like magnets, attracting the smaller ones and shaping the structure of groups and clusters of galaxies. However, gravity does not just attract, it can also cause spectacular collisions. Can you imagine two galaxies colliding? When this happens, new stars can form from the gas and dust that are compressed during the impact. This phenomenon is a reminder that the universe is in constant change, and gravity is the force that orchestrates these transformations. What about black holes? These mysterious entities are a testament to the power of gravity. When a massive star exhausts its fuel, its core collapses under its own gravity, creating a black hole. These objects are so dense that not even light can escape from them. But in the context of the expansion of the universe, black holes also play a crucial role, affecting the movement of the stars around them and feeding on the matter that comes too close. Gravity also helps us understand the concept of the expansion of the universe. As the universe expands, galaxies move away from each other. But why don't they move away from each other at the same speed? The answer lies in gravity. Although the universe is expanding, gravity continues to act as an attractive force, keeping galaxies together within their clusters. It is a delicate balance between expansion and gravitational attraction. As we explore the universe, we encounter astonishing structures such as the cosmic web, which is how matter is organized on a large scale. This web is made up of filaments of galaxies that intertwine, creating voids and clusters. Gravity is fundamental to this framework, guiding the formation of these structures and ensuring that the universe is not a chaotic place, but an organized system. Have you ever wondered what would happen if gravity were different? If the gravitational force were weaker or stronger, the universe would be a completely different place. Galaxies might not have formed, or they could have collapsed under their own gravity. The stability of the cosmos we know depends on this fundamental force and its interaction with matter. When we talk about gravity, it is easy to forget that it is not just a force acting on Earth. It is the same force that keeps planets in orbit around the Sun and moons in orbit around their planets. It is the reason stars do not scatter in space, but group together in galaxies. Gravity is the force that unites the cosmos. However, gravity is not without its mysteries. Despite its omnipresence, there are aspects of gravity that we do not fully understand. For example, the relationship between gravity and dark energy, which is driving the acceleration of the universe's expansion, remains an enigma. How do these two forces relate in the grand scheme of the cosmos? As science advances, researchers are developing new theories and experiments to unravel these mysteries. Gravity is an exciting and active field of study that continues to reveal surprises and challenges. From creating complex mathematical models to observing astronomical phenomena, the search for answers goes on. The influence of gravity extends beyond the physical. It also has philosophical implications. It leads us to reflect on our place in the universe and how we are interconnected with everything around us. Gravity not only keeps us on Earth, but also links us to the stars and galaxies, reminding us that we are part of something much larger. In conclusion, gravity is more than just a simple force. It is the essence that shapes the universe. It helps us understand how galaxies are organized, how stars behave, and how the cosmos evolves. As we explore the secrets of the universe, gravity remains a constant companion on our journey of discovery. It is the thread that connects all elements of our existence in this vast and mysterious cosmos. Modern cosmology has experienced an impressive surge in recent decades, becoming a fascinating field where science and curiosity intertwine. But what does modern cosmology really mean? To understand it, we must first address the question, how has our perception of the universe changed in recent years? A fundamental aspect that has revolutionized our understanding is the ability to observe the universe in different wavelengths. We are no longer limited to visible light. We can now explore the cosmos through X-rays, microwaves, and radio waves. This allows us to see phenomena that were previously invisible, such as the cosmic microwave background radiation, which is like the echo of the Big Bang. Imagine a vast ocean of information, where each type of wave is a different wave that tells us a unique story about the universe. But how does this translate into concrete discoveries? One of the most exciting advancements has been the confirmation of the existence of dark energy. Through careful observations, scientists have been able to measure how galaxies are moving away from each other, discovering that the expansion of the universe not only continues but is accelerating. This has led to the intriguing question, what is this mysterious energy that drives the expansion? The answer remains an enigma, but the fact that its existence has been identified is a significant step forward. Another area that has seen notable progress is the understanding of dark matter. Although we cannot see dark matter directly, its influence is undeniable. Through studies of galaxies and galaxy clusters, scientists have been able to infer its existence. So how do we know it's there? It's like observing a river. Even if you don't see the water flowing, you can see how the leaves and debris around it are carried by the current. Similarly, dark matter leaves its mark on the behavior of galaxies. A recent development that has captured the imagination is the idea of the multiverse. This theory suggests that there could be other universes, each with its own physical laws and characteristics. The question is, if there are infinite universes, what does that mean for our understanding of reality? Could there be versions of ourselves in these other universes? This concept challenges not only physics, but also our perception of existence. In this context, the cosmological principle has taken on a new meaning. This principle holds that, on a large scale, the universe is homogeneous and isotropic. But what does this imply for us? It means that, although our corner of the universe may seem unique for the most part, it is governed by the same physical laws everywhere. However, the variability in large-scale structure and the distribution of matter reminds us that homogeneity is not always perfect. Computer simulations have also played a crucial role in modern cosmology. Thanks to them, scientists can model the evolution of the universe from the Big Bang to the present. These simulations are like a virtual laboratory where the interactions of matter and energy can be observed in real time. But what discoveries have emerged from these simulations? Some have revealed surprisingly precise details about galaxy formation and the structure of the cosmic web. Furthermore, the study of gravitational waves has opened a new chapter in our understanding of the universe. These waves, produced by cataclysmic events like black hole mergers, offer us a new way to observe the cosmos. Imagine being able to hear the universe instead of just seeing it. This auditory approach is leading us to discoveries that once seemed impossible. However, despite all these advancements, many questions remain unanswered. Will we ever fully understand the nature of dark energy? What role does gravity play in the expansion of the universe? Each answer seems to open the door to more questions, making research in cosmology an exciting and dynamic field. The path to understanding the universe is a constantly evolving journey. Each discovery invites us to rethink what we know and to explore the unknown. Modern cosmology not only seeks to answer questions, but also to inspire curiosity and wonder in all of us. As we continue to investigate, it is essential to remember that science is a collaborative process. Advances in cosmology are the result of the hard work of thousands of scientists around the world, each contributing their piece to the cosmic puzzle. The quest for answers to the deepest questions about the universe is a collective effort that transcends borders. In the end, modern cosmology is not just about understanding the universe we inhabit, but also about comprehending our place within it. Each discovery brings us closer to the essence of what it means to be human and to our connection with the vast cosmos that surrounds us. So, what does the future hold in this endless quest? Only time will tell. But one thing is certain, we are only at the beginning of a fascinating journey. The idea of a center in the universe raises fascinating questions about our existence and the place we occupy in the vast cosmos. If there is no central point, does this mean we are lost in a sea of stars, floating aimlessly? The reality is that this perception of no center can be liberating. Instead of being a mere point in a vast void, we are part of an immense cosmic network interconnected with everything around us. When we reflect on the nature of the universe, we encounter a perplexing question. What does it mean to have no center? In everyday life, many of our experiences are marked by centers, from home, which is our refuge, to cities that function as hubs of activity. However, in the universe, everything changes. Imagine an expanding sphere. Every point on that sphere moves away from the others as it grows. This is how the universe behaves. Each galaxy moves away from us, and we from them, as if we are all part of a great cosmic dance. This concept of a centerless universe invites us to rethink our perspective. If there is no center, where do we place our sense of belonging? This is where connections come into play. Every star, every galaxy, every form of matter is part of a larger whole. We are united through forces like gravity and energy, forming complex structures that shape our universe. Thus, even though there is no center, there is a sense of cosmic community that envelops us. The philosophical implications of living in a centerless universe are profound. We face the idea that we are a product of evolution, a small fragment of a vast tapestry. This can make us feel insignificant, but it can also inspire us. The absence of a center reminds us that we are explorers on an endless journey of discovery. We are not alone in this journey. Each individual and each discovery contributes to the story of the cosmos. When thinking about human existence, another intriguing question arises. What role do we play in this vast universe? If there is no center, do we have importance? The answer is a resounding yes. Each of us has the power to observe, understand, and marvel at the greatness of the cosmos. With our curiosity and creativity, we have built telescopes and spacecraft, challenging the limitations of our environment to uncover the secrets of the universe. As we explore beyond our planet, we realize that each discovery opens new doors. What lies beyond what we know? Can we come to understand the forces that shape the universe? The quest for answers drives us forward, even if the notion of a center fades. Curiosity becomes our compass, guiding us through the darkness of space. However, the fact that there is no center can also create anxiety. In a world where we often seek direction and purpose, the idea of a chaotic universe can be daunting. But if we look closer, we find that this apparent randomness is, in fact, an underlying order. The laws of physics, the interactions between particles, and the dance of galaxies reveal a deep balance in the vast complexity of the cosmos. In this search for meaning, questions about the nature of existence also emerge. What does it mean to be human in such a vast and sometimes indifferent universe? The answer to this may be as simple as recognizing that our desire to understand the cosmos is itself an act of meaning. The fact that we question, explore, and dream is a sign of our uniqueness as a species. The notion of a centerless universe also invites us to consider the unity of human experience. Despite our differences, we all share the same home, this blue planet spinning in a corner of the vast darkness. We are united through curiosity, a love for knowledge, and the search for answers. In this sense, the universe can be seen as a mirror reflecting our aspirations and fears. As science advances, we find new ways to understand our existence. The theories of relativity, quantum physics, and modern cosmology offer us tools to explore our reality. But at the end of the day, the real challenge lies in how we integrate this knowledge into our daily lives. How can we use these ideas to foster a greater connection with our environment and among ourselves? The absence of a center in the universe does not mean we are devoid of meaning. In fact, it can be an invitation to create our own center. Each of us can be a beacon of light in the vast darkness, illuminating the way for others. By finding purpose, even in an apparently chaotic universe, we can make a positive impact on our communities and the world. Ultimately, reflecting on the center of the universe leads us to a call for humility. We are just a small part of a vast whole, and recognizing this can be liberating. By accepting our position in the cosmos, we find the opportunity to look beyond ourselves, to cultivate empathy, and to work together for a better future. So even though there is no center in the universe, there is a center in our lives. It is about the connections we form, the stories we share, and the dreams we pursue. Ultimately, what truly matters is how we choose to navigate this vast ocean of stars together. Is it possible that there are other universes besides our own? The idea of a multiverse has captured the imagination of scientists and philosophers alike, challenging our understanding of the cosmos. But what does this theory really mean? The notion that there are multiple universes raises profound questions about the nature of reality. If there are other universes, what exists in them? Are they exactly like ours? Or are they governed by completely different physical laws? These are the enigmas that lead us to explore the fascinating concept of the multiverse. One way to understand the multiverse is to think of a vast library filled with books. Each book represents a different universe with its own stories, characters, and rules. Some books may resemble ours to a great extent, while others could be completely strange. The multiverse theory suggests that our reality is just one of these stories in an infinite library. But how did we arrive at this conclusion? Scientists have developed several theories that support the idea of the multiverse. One of the most well-known is the many worlds interpretation of quantum mechanics. According to this interpretation, every time a decision is made in the universe, all possibilities materialize, creating multiple realities in which each option becomes a separate universe. This means that in one universe, you might have chosen a different career or even taken a different path in your life. But how can we verify that these realities actually exist? Another perspective comes from cosmic inflation, an extremely rapid expansion phase that occurred just after the Big Bang. During this inflation, bubbles of space were generated, each of which could be its own universe. Imagine these bubbles as soap bubbles forming in an expanding space. Some bubbles might merge while others may remain isolated. Each bubble would contain its own physical laws and constants, thus creating a multiverse full of diversity. However, the idea of a multiverse is not just a theoretical exercise. It has profound implications for our understanding of life and existence. If there are infinite universes, what does that mean for us? Are we destined to be an echo of alternative realities? Or are our choices and experiences unique and valuable in this vast cosmos? These questions lead us to reflect on our place in the universe and the nature of reality. The search for evidence of the existence of other universes is a monumental challenge. In science, observation and experimentation are key. But how do we observe something that is beyond our own universe? Some scientists propose that the traces of other universes could manifest in the cosmic microwave background like echoes of past events. But can we really trust these clues, or are they just illusions? Furthermore, there is the dilemma of falsifiability. In science, a theory must be falsifiable to be considered valid. But how can we refute the existence of universes that we cannot observe? This is a point of debate among scientists. Some argue that the multiverse theory is more philosophy than science, while others believe that, although it is difficult to prove, it is worth exploring. The philosophical implications of the multiverse are equally fascinating. If there is an infinite number of universes, does that mean that every possible story has already occurred? Does that imply that all our dreams and desires have a place in some universe? The idea that our lives are just a variation in a sea of possibilities can be both liberating and terrifying. It confronts us with the question of whether our choices truly matter, or if we are simply navigating an infinite current of realities. The concept of the multiverse also raises a question about the nature of creation. If there are infinite universes, who or what created them? This question may lead us to reflect on the existence of a creator or forces that transcend human understanding. Is the multiverse a product of chance, or is there a purpose behind its vastness? On a more practical level, the multiverse theory also has implications in fundamental physics. Scientists are trying to find ways to unify quantum mechanics and relativity. And the multiverse could be a key to understanding how the cosmos works at its deepest level. Research on dark matter and dark energy, for example, could benefit from an approach that considers the existence of multiple universes. As we move into the future of cosmology, the multiverse will remain a hot topic of debate and exploration. As new theories and technologies develop, we may find unexpected ways to investigate the existence of other universes. Human curiosity continues to push us forward, challenging the limits of what we know and what we believe we know. So, where does this leave us? The search for the truth about the multiverse is an intellectual adventure that invites us to question our reality. As we explore the possibilities, we not only expand our understanding of the cosmos, but also confront profound questions about life, existence, and our place in this vast and mysterious universe. The exploration of the multiverse could be one of the greatest odysseys of modern science, and each step we take brings us a little closer to discovering the truth about reality. Have you ever felt the need to find a place to call center? In our daily lives, we seek a point of reference, something that helps us orient ourselves in space. But what happens when we talk about the universe? Throughout this cosmic journey, we have explored the idea of a center of the universe, but in the end, we come to a surprising revelation. Perhaps there is no center. Imagine the universe as a gigantic balloon. As we inflate the balloon, every point on its surface moves away from the others. If you draw a line between 2 points on the surface, you will notice that both are separating. In this analogy, there is no specific place that can be pointed out as the center of the balloon. Instead, all points are equally valid, and in some way, the universe operates similarly. Each galaxy moves away from the others, and there is no privileged place that can be called the center. Now, what does this mean for our understanding of the cosmos and our place in it? Often we think of Earth as the center of everything, but science has shown us that we are in a corner of a galaxy, which in turn is just one among billions. This shift in perspective is fundamental. Instead of being the center of the universe, we are observers on a vast cosmic stage where every star, every galaxy, and every black hole has its own role to play. And what about the idea that the universe is expanding? This is one of the most exciting revelations of modern cosmology. When Edwin Hubble observed that galaxies were moving away from each other, he opened the door to understanding that the universe is not only immense but also constantly changing. Imagine a cake where each piece represents a galaxy. As the cake bakes and expands, the pieces separate. This is how the universe works. It is expanding, and with it, our ideas about what it means to be at the center. What about the matter and energy that make up everything we know? Dark matter and dark energy are fundamental components of our universe, although we still do not fully understand their nature. Dark matter acts as an invisible skeleton that holds galaxies together, while dark energy seems to be responsible for the acceleration of this expansion. These mysterious forces remind us that despite our advances, there is much to discover. Reflecting on our search for a center, we cannot help but ask, what implications does this have for our existence? If there is no center, are we less important? On the contrary, this gives us a unique perspective. Each of us is part of a vast cosmic tapestry that is woven throughout time and space. Our actions, thoughts, and feelings have an effect on the universe, no matter how small. The ideas we have explored so far are not only fascinating from a scientific standpoint, but also have profound philosophical ramifications. The absence of a center leads us to question our identity and our place in the cosmos. Are we alone in this vast expanse? The multiverse theory suggests that there could be other universes, each with its own rules and realities. This opens up a range of possibilities that challenge our current understanding of existence. As we have seen, modern cosmology offers us a constantly evolving landscape. With each new observation and discovery, new questions arise. Perhaps the search for a center is not the most important thing. Maybe the essence lies in curiosity itself. Each question we ask brings us closer to the truth, and each answer leads us to new questions. The journey does not end here. Science is constantly changing, and with it our ideas about the universe and our role in it. Gratitude for human curiosity is the driving force that propels scientists and thinkers to continue exploring. As we look up at the starry sky, let us remember that each star, each galaxy, is a reminder of what is still left to discover. In conclusion, the idea of a center of the universe is an intriguing concept, but it is likely to present itself as an illusion. Instead of seeking a central point, we should embrace the vastness of the cosmos and all the mysteries it holds. The beauty of the universe lies in its complexity and in the infinite possibilities it offers us. In the end, we are part of a whole, and each of us has a place in this magnificent work of the cosmos. So the next time you look up at the night sky, remember that even though there is no center, each star shines with its own light. And each of us has a unique role in this wonderful story of the universe.